Alrighty, welcome back to Virtual Notes. We are going to continue with forms. So right now you have the general knowledge that there are two forms, as far as you know, that you can write a linear equation in, one being slope-intercept, the other being point-slope form. So in order to get to this third form, which is sort of weird, what I'd like you to do is just think of the equation of a vertical line, and just blurt that out. All right, very good, very good. Okay, I'll use that one. Surprising that you said that, because I already had that on my piece of paper. So this is a vertical line. We know that, right? So if I had asked you, hey, what form is this written in? What would you say? I mean, you only have two choices. So those of you that would have said, well, I guess slope-intercept. I mean, think about it. If I really were to write it in this form, we know the slope of this line is undefined. Okay. We know that the y-intercept, well, there isn't one, right? It doesn't even cross the y-axis. Again, if you need a picture of this thing, it looks like this: x equals 4. What about a point? Do we know a point on this line? Yes, that is true. Anything that has an x-coordinate of 4, so let's go with like 4, 7. That would be a point, right? So let's see, can we write it with this information in any of these forms? Not really. What does slope-intercept form look like? Y equals undefined x plus none. Oh, that's a nice looking equation. Not good. How about point slope? We can do that one, right? Because now we got a point. So it's y minus 7 equals, oh, still this undefined thing is the big issue here, times x minus 4. So neither of these are looking real good. So we have to have a form that we can say that this equation is in, because it exists. Well, there comes our third form, and the reason for it. Our third form is standard form. Okay, and standard form looks a little bit like this: capital A, x, plus capital B, y, equals capital C. And I want to make sure you write those in as capitals. That's important. When we look at this, we basically know that A, B, and C must be integers. Anybody remember what an integer is? I'm hoping. We've got basically, positive and negative whole numbers. So really what I'm saying is A, B, and C, they cannot be fractions or decimals. Okay, so we'll have to get rid of fractions and decimals if we see them. Okay, so what about that vertical line, x equals 4? That doesn't really look like this form, but if we had to really look at it, we could figure that what would the a value be, right? Coefficient of 1, so not that I would ever write it, but that's really a 1x. What would the coefficient of b have to be? The integer 0. Right? Because 0 times y would be 0, and therefore that's why we don't see a y up there. And then simply is equal to 4. So there you go. You've got your standard form for a vertical line. Now we know we would never ever write it this way. We would simply just write it as x equals 4. Okay, so standard form it is. Now here's the annoying part about standard form, is the fact is that unlike these two very useful forms, where we can take information out, this one's got nothing that we take out of it. For example, if I write the equation 3x plus 5y equals 10, and I ask you, all right, what's the slope of this line? All you that wanted to say 3, give yourself a little, no, I'm smacking my hand there. No, it's not 3, because we can't identify the slope until it's in slope-intercept form. Y-intercept? Oh, maybe 10? No. Nope, not true, because again, not until it's in slope-intercept form. What about a point, right? Maybe a point, like 3 comma 5? Well, if you want to go there, just plug it in and see if it works. 3 times 3 would be 9, plus 5 times 5 is 25. That's not going to get you 10. So we literally can take no information out of something that's in standard form. We have to remember that. Similarly, if I give you information and I ask you to write something in standard form, you can't go that route either. So what are the types of things that you're going to need to be able to do with standard form? Well, I might ask you to rewrite in standard form. See, my music ran out there. The following. So I'll give you, let's say, 3/4 y equals, totally making up a random equation. Okay. So is this in standard form? Well, no. You know it's in standard form if you have your x term first, your by term second, and your constant term last. Well, the only thing that is sort of in its right place right now is the 7. That would be the last thing. Although I got this 2x to get rid of. And then I have 2/3 x to get rid of. And then I have this thing right here, the 3/4 y. That's actually kind of in the right spot, right? I want the y term up against the equal sign there, so that's cool. So let me see if I could, oh, well, let's get rid of the x term by subtracting 2/3 x. I subtract 2/3 x. Now I have, instead of writing 3/4 y minus 2/3 x, since I want the x term first, I'm just going to put negative 2/3 x plus 3/4 y equals 7, right? Now, is this in standard form? Let's see. The x term, good. Y term, good. The constant term, good. But a, b, and c must be integers. These are not integers, so we got to get rid of them. Any clue how we would do that? How do we get rid of a denominator? Well, yeah, we could multiply by 3. That would get rid of this one, but not that one. We could multiply by 4, would get rid of this, but not that. Oh, we got to multiply by a common multiple. In this case, multiplying the entire equation by 12 will help us out here. So let's see, 12 times 7 is going to get me a, help me out, 84. Alrighty. 12 times 3/4 is going to get me a 9y. And 12 times negative 2/3 is going to get me a negative 8x. All right, things are looking good. Now, here's the other thing you got to be aware of with standard form. It could be that somebody else, moved the 3/4 over here and moved the 7 over there and did a lot of different things, and instead of getting this equation, they might have gotten this equation. Anybody notice what's happening here? Yeah, you have exact opposites. And guess what? These are equivalent equations. So because they're equivalent, meaning they're going to have all the same solutions, they'll have the same slope, they'll have the same y-intercept, they are the same line. And so this is just as correct as this one. So before you argue with your friends about who's right, who's wrong, check to see if you have equivalent equations. Okay, so what if I gave you one with decimals, like I'll just put it already, where we have 1.3x minus 0.25y is equal to, oh, you can't see that, can you? Oh, there you go. Equals to 8. So here's our equation. Is it in standard form? Well, the x is first, the y is second, and the constant term, but I got decimals. These are not integers. So how do we get rid of decimals? Okay. How about multiplying by the power of 10 that matches the number of decimals you want to get rid of? So I got 2 decimal places I want to get rid of, so I'm going to multiply by 10. No, kidding. 100. We wind up getting the 100 to each one of those things, and you wind up with 130x minus 25y equals 800. You're like, what are we doing? Why are we dealing with this equation? It seems annoying. Remember, it is necessary, and it isn't in standard form until you got rid of your decimals and your fractions. So now it is. It's all good. We are in standard form. Okay, so this has been standard form, your introduction to standard form. Do I want to go further with it? Yes. What if I ask you to write an equation in standard form? Write an equation in standard form. Give with the given information. With the given info. Oh man, we're over 10 minutes. I got to wrap this up. So here we go. This is the last part. So I tell you that the slope of a line is, let's go with, anybody want to, negative 4/7, that's fine. And a point, always choose an x, that's going to be nice. I like 21, -6. That's a nice one. So here we go. I want, with a line with these characteristics, meaning a slope of negative 4/7 and going through this point, I want to see what that looks like in standard form. So let's remind ourselves what standard form looks like. AX plus BY equals C. What do I plug that in for the A? Oh, I got it. No. This is an X, right? And that's a Y. So I'll plug that in here for the A and that for the Y. And I'll just throw this. No. You can never go from here to there. Never go directly there. How can we get from this information to here? Well, we have to take one of these little vehicles. You might recognize this vehicle, or this one. I don't know what I'm drawing. Just go with it. Okay, and these vehicles are the y equals mx plus b vehicle and the y minus y1 equals m times x minus x1 vehicles. Sweet. So yeah, you actually have to go with this information through one of these vehicles. You don't have to go through both. So you would either go from there to there and then go to that. So let's see how that's going to look. What do you guys think? We're given a slope and a point. We could go right to our newfound friend. Let's do it. We wind up with y plus 6 equals negative 4/7 times 21. Times x. Sorry, I'm like thinking about the time that this has been running on now. X minus 21. All right, stick with it. Now we're going to distribute the negative 4/7, so that gets us y plus 6 equals negative 4/7 x plus, negative times negative, cancel, 12. And then we're going to subtract 6 to both sides, and we have y equals, oh look, we just took a pit stop at the old slope-intercept form. Now you might be like, well, why didn't we just go there first of all? Well, remember, if we did that, we would have had to find b, so we would have done similar math to get to b. Now that we're here, I want to get to there. So all I have to do is add 4/7 x to both sides. I now have, I'm almost off the page there, I have 4/7 x plus y equals 6. Anybody? What do I have to do? Last step. All right, let's wrap this thing up. Multiply by 7 to get rid of that denominator. No fractions allowed. Get the 7 to the y, you're there, times the 6, you're there. Hey, looking good, standard form. Standard form it is. We did it. Nicely done. All right, so to wrap up, to conclude, we now have 3 forms. Uno, dos, tres. Very useful forms for taking information out and plugging information in. Not so useful, but extremely mandatory form. I mean, without it, we could never really say that the equation of a vertical line was in any form. And just remember, we got to get rid of fractions. Never allow them. Or decimals. Never allow them. And therefore, we can now take information. Whoops. We can now, decimals never allow them, we can now take information, go through our little vehicles, and transform that into standard form, just like we did there. All right, I hope that's pretty clear. Sorry for us running on. Keep it under 15 minutes, and we did it. All right, have a good weekend, guys.